Good morning, everyone. It's really nice to see you here, um, especially knowing that, again, like our good friends from Google are talking on the other stage about animations, right? In our case, we're going to be talking about Flutter at scale. My name is Jorge, and probably if you're here, either you've seen this talk and you liked it, or you've seen this talk and or you didn't know about it. But pretty much I already gave a similar talk back in summer at DroidCon New York, 2019. But a few things have changed since then. If you see that slide, uh, this is the 2020 edition. It's not 2019 anymore. A lot of things have changed, right? We have extension methods. And blah, blah, blah. No, what has changed? In 2019, I was working for a certain German car maker, but now I work for Very Good Ventures, coolest logo ever. And that has changed a few things, right? It has changed that a few things that I've been saying during that talk, they were just applied to, in this case, the world of BMW, right? And the challenges that we're facing there. But now, as a employee of Very Good Ventures, I get to talk to many different clients, partners, right? And talk about like their challenges, right? And their challenges might not be the same challenges that we faced when we were working at BMW, right? Could be like a different set of like developers with a different background or like a different experience or like they're not rewriting their application. They might just wanting to add a module and things like that. But pretty much what I want to say is like that has opened me to be exposed to more code bases, right? Has helped me to be more exposed to certain like microservices, REST APIs, or like you name it, right? And also like many different mobile challenges, right? So that to me, you might think that, oh, like probably you have to challenge some of the preconceptions or ideas that you had before. And it did, but like I think one of the good things is that if you have certain like coding values or certain goals in mind or a certain mission, right, that it's understood by everyone in your team, actually with very simple ideas, you can accomplish a lot. And then, as Brian Egan was saying before in his talk, it's all about picking the right tool for the right job, right? So, of course, I have my set of preferences, but like in this world, you have to be also like flexible, right? So we're gonna talk about that. So we're gonna set some goals, some boundaries for what we mean for development at scale. That sounds very fancy, but it's actually not that complicated. And then we're gonna go through those, right? And I feel like I could do this talk just focusing on many other tools, but I have 45 minutes, so I'm gonna just give you what's my preference. But again, we can talk about more about it later with a different set of tools and conditions, right? So first of all, what do we truly mean by Flutter at scale, right? Or in reality, what do we mean by anything at scale? You might be thinking that, oh, it's you have like 100 developers, so 99 is not at scale, it's only 100 and more. In reality, no, it's about like, we're gonna face a problem. Usually it's a complex problem, right? Doing mobile applications or like UI development in this case with Flutter is not trivial, but we're only gonna make it an interesting problem to solve and something that we can scale or continue growing on top of that solution if we provide an easy solution. And I know that this sounds kind of like, yeah, of course, like that's what everyone dreams of, right? It's not easy. And again, like if I quote Brian Egan's, he spent like 5 years working on RxStar, and it's always like an ongoing problem, right? Or an ongoing challenge. So first of all, what do we mean by a problem, right? So I actually went to the dictionary and tried to see what do they mean by a problem. And it's literally like a question that needs to be answered, right? But like usually that presents certain challenges, right? Like you want to expose it and get a solution. Like in mathematics, from a scientific point of view, is like you just have like a preposition and you want to get to a final path. You want to get an answer for that. Like if you think about it from a human point of view, from a psychological point of view, it also creates anxiety sometimes, right? Like you're facing something that it's unknown, something that gets you out of your comfort zone, and that's tricky sometimes, right? And we need to acknowledge that part. So in our world, in the world of programming, like the way we solve these problems is with two things: with APIs, really nice, clear APIs, right? But also with positive and efficient communication. Like we cannot think about programming without comparing the human, or like without making sure that we put in the equation the human aspect of it, right? Like at the end of the day, we're developers. The way we exchange feedback is through communication. The way we actually set goals or like requirements is through communication. And usually, like we see that if it's not efficient, if it's not positive, first of all, doesn't lead to a good API, but it creates actually human anxiety. And that's something that ultimately we don't want to have, right? So in this case, if we just target like UI development, what are the problems or what are the challenges that we face usually? And this is part of the kind of like setting the boundaries for development at scale, regardless of the number of people working on the project, right? Well, usually we want to make things simple, right? Like if things are complex, if things are hard to do, usually it gets very, very tricky. It's hard to abstract. It's hard to like incorporate all the variables, all the different states, all the different things that could go well or wrong, or you have to take into consideration. Also, you want to be more productive, right? At the end of the day, what we do is somehow like provide business value, and that has to be translated into like productivity. Either as a developer, you want to do certain things in a faster way. You don't want to do boilerplate, but also businesses, they want to remove that overhead, right? And therefore means like, how can we bring actually the money bill down, right? Probably like free is not better than always like a certain amount of money in this world, right? But yeah, you want to be cost efficient. And finally, how can you actually guarantee that with all these things, you can still be robust? You can guarantee that your stuff, the things that you were planning and working on, they're robust, like they're not gonna break over time, right? So with that, what happens? We have in there like a few keywords that we're gonna set as our baseline for development at scale, right? We wanna simplify and improve. We wanna be productive, cost efficient, and robust, right? Do you have a framework in mind that kind of like checks all those boxes? Yeah. I mean, we're at a Flutter conference. I'm not gonna talk about JavaScript. Yeah, so for me, Flutter and Dart is actually a perfect tool for these constraints, right? Why? Because when we're talking about simple and UI-oriented problems, it gives us widgets. And widgets are incredibly powerful and easy to understand, right? Like you've heard this, like almost everything is a widget. And we're talking about two APIs, a build method, or like if you're talking about a stateful widget, it's a create a state plus a build method in your state. And with that, think about all the things that you can accomplish, right? So that's what like gives us simplicity, the widget framework. We're productive, right? With hot reload. Like it saves us development time. Like we can change code on our editor, save that file and see the changes immediately. It's cost efficient because we can get things done in a single code base as opposed to like multiple code bases, right? And finally, we get that robustness, that like security that what we're doing can be reproducible and like we can test it with different different testing frameworks. Like we have unit tests, we have widget tests, we have driver tests, right? So with these four things, think about it for a second. I'm not even talking yet about tools. I'm just saying that Flutter itself as a tool without any other extra dependencies is already like a tool that is going to enable you to develop at scale, right? With those four boundaries. But always, probably we can think about certain things, right? To like improve or like keep actually growing and like abstracting more of these complex ideas into more simple solutions. So let's think about these four ideas. We want to find things that are simple, productive, cost efficient, and robust. And I feel like a machine that is repeating the same thing over and over again, but these are the boundaries that I have identified as like, this is what we need to make sure that we're giving a consistent, scalable code base, right? So if we find a tool or we're doing something that breaks one of these pillars, I think that that's going to be trouble later. I think that it's not going to help you to scale, right? However, if we find tools, practices, patterns that are going to actually elevate any of these four pillars, it's going to increase our productivity, it's going to make us happier as developers, right? So that's very, very important. So let's think about it for a second. What can we do? Is there anything that we can do within the Flutter world that it's going to help us to be even more simple or more productive or like most cost efficient or even more robust? That's what we're going to be talking about now, right? So first of all, what is Flutter? Flutter is a UI toolkit, right? It's all about UI. Anywhere where you can paint pixels, ideally you should be able to use Flutter. And that's why they're targeting like mobile, web, desktop. But I don't know if you have even seen like some of these like demos that they put during Google I/O or Interact. They had at some point like a wall full of LED panels, And they had Flutter running on there, right? Because it's just a matrix of pixels, right? So pretty much anywhere where you can paint, you should be able to run Flutter. It's just about adapting in this case, the embedded engine. And what's UI after all? I'm sure that everyone has seen this slide in many different formats, but like UI at the end of the day is just like a function of your state, right? Like the things that you want to paint on the screen and how you modify the things that you're painting is what's going to actually enable you to do some of these things. So knowing that the UI is a function of a state, we know that actually state management is a really, really big topic. And let me state something very, very clear from the very beginning. I don't believe that there's like a right answer for state management versus like a wrong answer. It's just a set of tools. In most of the cases, you're gonna know about your background, the background of your team if you work on a team or like whatever it is, right? And you're gonna, from that background, from that set of constraints that you already have, you're gonna have a preference, right? And I think that pretty much every single state management solution, as long as it follows that idea that like you can make it simple, you can make it cost efficient, you can test your code, it's okay. It's just a preference. However, I would say like go for it, try it by yourself. Set a state is what like every state management tool is going to be using. It's great, super powerful. Redux is a great tool if you're coming from a web background where you've worked with Redux before, like, or even if you haven't had like any Redux background, it's a great tool as well. Movex, I don't know, scope model, provider, many others, like I don't know how many they are. Pick it. Just try it by yourself. See how you like it. See how you don't like it. Make an informed decision, right? Like maybe even document, write an article about it, right? Like sharing that experience is super positive for the entire community. Now I'm here in the States, so I'm gonna give you what I think it's, to me, like what has worked for me and my team to actually help us scale, right? However, I would say something. Please, please, please don't be that developer that is like, no, I have my own like way of doing things. It's all in my head, and that usually doesn't play well because first of all, there's like if it's in your head, it's not documented anywhere, right? So that learning process is missed. Like you cannot share your thinking process unless you put it somewhere in documentation or with code examples and things like that, right? And that's very important when you work on a team, right? So if you have something that works great for you, go for it. Just try to open source it, create a package, share it with the community, get feedback, and everyone can grow and learn. Maybe you even get like to be on the stage next time. Like I don't know, right? But like just don't be that developer that keeps things to itself. So I said that I'm here on the stage, right? So for the rest of the talk, I'm going to talk about the tools that, for me, they've been working great. And again, it's just a preference. I'm not saying like this is the only thing that works. But I'm going to show you how it worked for me within these 4 constraints that we put before, right? Simplicity, productivity, cost efficiency, and robustness, right? So if you follow me on Twitter, like probably you know what's going to be what I was recommending, right? Like work with Felix Angelov is a great teammate. He put together this library called BLoC. We started using this at BMW and realized like, hey, this is great. We can open source this, right? And the entire thing is like, it tries to make state management predictable. It tries to make it simple by honoring that every single application has a reactive component in a way that things can happen at any point in time, and you might have to react to that, right? But we come from an experience where like reactive patterns, while powerful, they were very complicated to our developers, to our teams, right? We gathered that feedback. We also had the experience of knowing that making it work in a robust way without like memory leaks, without like having to handle the subscriptions properly and things like that was very complicated. And also like we didn't have like unidirectional data flows, right? Which is something very important if you're trying to debug. So with BLoC, it was an answer that checked the boxes for us, right? And one of the cool things is like it's separated into pure Dart components and Flutter or Angular Dart components. Angular maybe not be that relevant anymore with Flutter Web, but still it's relevant somehow. So that's pretty good, right? Like pretty much you can apply BLoC even to CLI programs or whatever. It's just about how to state management, like how to manage state. And that is not actually truly related to UI problems. Could be any type of application, right? It's just like there's a convenience package for Flutter that is going to help you to kind of like consume what's going on the BLoC side. So a little bit of advertising. He's actually speaking later at 2:30. So if you're interested, go, or even just introduce yourself, say hi. He's sitting over there. He's gonna hate me for doing this, but he's actually like super knowledgeable, a great member of the community. So I truly, truly encourage you to just at least say hi, right? All right. So why did we pick BLoC? Well, again, like I'm gonna show you why it checks all those boxes, right? Like it's simple, it's predictable, productive, and robust. And it's all based on what idea? I said that we honor that it's a reactive pattern, but what we did is to simplify the amount of streams and sinks that you can expose through your BLoC. There's only one stream, right? Like only one thing can get out of the BLoC. And there's only one sink. Only one thing can get inside the BLoC. And by doing that, now you shift the paradigm a little bit. You can simplify things because you own that API, that single stream or sink, and you can do actually very cool things. So as you can see in here, we have three kind of like different domains or three different worlds: our UI component, our BLoC in the middle, and then the backend, your asynchronous code, data sources, whatever you want to treat it, right? And it could be synchronous or asynchronous code. So let's take a look to an example, right? Everyone has seen when you create a Flutter project, the counter example. It's very simple. You tap on a button, and it's going to be an increment of the counter, right? And we see that the state is updated. In this case, what we have in here is the BLoC side. So very simple, small class. The first thing that we're going to do is to start with an initial state, the first state or the first frame that it's going to render with this state, right? We start at counter at 0. Very simple. And then we're going to have this other API that it's called map event to state, right? So you can think about it already that we're going to receive an event, probably like something that is going to look like increment, multiply, decrement, some kind of, hey, the UI, someone in the UI is asking for this operation. And then what we're going to do is to give you the consequence of that event, right? So in this case, counter that decrement is the event. And what we're going to do is to yield a state. As you can see, there's no reactive code in this case. We're just modifying like code in a very like if-else synchronous way, but there's a lot of asynchronous code going behind the scenes, right? Like I can receive this event at any point in time, but what we're trying to do is to simplify the logic behind it. I don't have to think about what's going on asynchronously. I just think about I receive a state, I react with these consequences. In this case, decrementing 1 my state. If I receive an increment, I do the opposite. I increment my state by 1, and I yield it, right? So far, so good, right? Easy. And then what do we do on the UI side? Well, we have in this case our counter page, and we can see that it's a stateless widget, right? So the first thing that we might need to do inside our build method is to get access to this BLoC. And BLoC actually behind the scenes uses one of the most used packages for the AI provided, right? We're just putting our BLoC, our model, probably in the widget tree, right? And with that, now we can do a couple things. In this case, we have a BLoC builder, right? So every time we need to paint again on the screen, we might need to set our state. We can put BLoC builder, and we're going to receive that state. In this case, we just want to update the counter. It's just a text field. I don't need to wrap the whole widget, just the area that I want to rebuild, right? So in this case, we put BLoC builder around our text field, and we just pass inside the count that we want to update, right? So every time we push a new state, text with the count is going to be updated. How do we access or how do we push events to the BLoC? Well, we had access to that BLoC initially at the top of our build method, right? So in this case, on the onPress of a floating action button, we just add an event to our BLoC, right? Add is part of the sync implementation. So in this case, we're just saying like, hey, increment, this is my event, right? It doesn't say how much you want to increment. That's part of the business logic. Same thing for the decrement step, exactly the same way. And we're going to notice that with just these pieces of code, you can actually do anything. You might be thinking, yeah, well, this is the counter example. It's very simple, right? Like, we don't need a BLoC for that. Well, what about if we talk about a network code, right? Like, what about some asynchronous code? Via constructor in this case, something that we call weather repository. So by the naming convention, we can already imagine that we're going to do something weather related, probably like fetch the weather from a server, right? So this is just like injection, nothing crazy about it. But we start again with an initial state. We don't know what's the initial state. It's empty. Therefore, we push a state that it's weather empty, right? And the UI can react, paint whatever it is. Maybe it's paint a text field to introduce the city name, or maybe it's a loading spinner, or maybe it's an animation coming from Drive, whatever you want. But we know that the business logic state is that it's empty. And then we're going to have an event. In this case, we call it fetch weather. How do we react to that? Well, the first state that we're going to meet is like, my weather is loading, right? It's going to do a network call. So the first thing to show to the user is like probably like a loading indicator. And then we're going to wrap our network call in a try-catch, right? Like it's just an asynchronous call, it's a feature. So we can wait for the result. Again, the last state that we pushed was loading. And once we receive those results from the weather repository, we can either emit that the weather was loaded for that city. As you can see, the city comes with the event. Or if there's an error, we can emit a weather error. So you can see it's the same convention as the one that we had for the counter block. In this case, we're making a network call and all the stuff, and we're not talking about crazy things, right? It's very like, if I get an event, I do this, I do this, I do this, right? So this checks the boxes for being very, very, very simple. What about productivity, right? Like maybe you're thinking like, oh yeah, that's great, right? But there's a lot of boilerplate, and I always have to write the same API. It's always init state, and it's always map event to state. So in this case, we actually noticed that, yeah, it comes with certain boilerplate, right? And we actually want to have certain structure in these APIs. We always want them to be in a certain order and things like that. So between Felix and myself, we created IDE tools, right? Like you can use VS Code or IntelliJ products to create all these boilerplate for you. So as you can see on the VS Code side, it's just like a right click, fill some boxes. On IntelliJ, it's just a dialog. It will generate this for you. So this also checks the boxes for productivity, right? All the things that you can do to shorten that cycle, we're trying to do it. What about robustness, right? Robustness is testing. And one of the cool things about BLoC itself is like it comes with this BLoC test utility, where like actually writing tests is very straightforward. Think about how everyone likes to write tests. You want to set up your scenario, right? Like set up your conditions, your testing conditions. You want to apply the side effects, right? Like you're going to modify, in this case, act, and then you're going to have certain assertions, certain expectations. So let's look at the structure of this test. We just have a title that says, when we actually decrement, what we're going to meet is 0, our initial state, and -1, that it's the consequence of my event, right? So in that case, we just build the BLoC, right? Like we create our testing case, our testing scenario. We're going to act on that BLoC. We're going to apply the side effect. And finally, we're going to validate our expectation. That's very cool, right? It's very powerful with just a few lines of code. What about the testing case of a network call? Again, it's always about following the same steps. You actually don't even think about it. Like you can like memory type everything, right? So let's look at this example. We say that we emit empty, loading, and error when the fetching weather from the network fails, right? So in this case, our build method, pretty much our setting up our test case, is very simple. We mock our repository and we say like, hey, when we actually ask for weather, just throw an exception. We want to trigger the error case, right? And just give me the weather BLoC. Then in our act, in our side effect, in our like trigger of the consequence, we just say like, hey, we want to fetch the weather for a certain city, Varsa in this case, right? And finally, we have our expectations. The first state is our initial state. We said that it was empty. And then if you remember the consequence of the event, there were 2 states. My loading state, as we can see here in the second expectation, and finally the last state, that it was the error, right? If we mock this repository to be a successful response, instead of a weather error, we would have in there a weather loaded. So very, very simple, very straightforward, always the same steps, right? Like that's what makes it very, very simple and easy to understand. So far, what are the things that we know about BLoC? That is simple, right? That is productive, cost efficient. Have we talked about that yet? Not yet. But we also know that it's robust. So what do we mean by cost efficient, right? It's like, we don't want to repeat tasks that we have to do over and over and over again. Sorry, I'm still getting used to the clicker. So to me, one of those tasks is analytics. It's horrible when you're like finished doing your feature, and then your product owner comes and like, it's time to do analytics, and then you have to start adding like your not print statements, right? But like to capture your analytics in a way that's like, oh, maybe I didn't set up the code in the right way or whatever. But also, it's really hard to debug sometimes the code, right? Like you say, hey, this bug that it's coming from this user is very, very weird. To reproduce, we don't have the steps. So wouldn't it be awesome if we had a tool actually that without us having to spend any extra effort would get all these things for us? Well, actually, BLoC has an answer for that. And it's called BLoC Delegate. With BLoC Delegate, it's very simple. We said that we just have a single stream and a single sink for every block, right? So by just knowing that we have that single API that BLoC can control, we can put like a spy in between that is actually keeping an eye on every single transaction, on every single thing that is happening. So in this case, BLoC Delegate gives us access to a non-event. So every time an event happens, every time an event is added to the block, we're going to get a notification, right? Like we're going to get kind of like a callback in this case. Every time there's a transition, we're going to receive the same thing. And the transition is pretty much, hey, you were on this state, this event came, and now you're going to push this other state, right? So it's very, very predictable. And finally, for whatever reason your block throws an error, then you can capture that in here as well. So let's say that it crashes for whatever reason and you want to blame Felix, that's fine. Like you just get it from here and that's it. And it looks something like this. So I'm going to show you logs of an application that you've never seen before, but you're going to help me to debug it, right? Because it's very, very simple, actually. These are the log statements that we may be printing from BLoC Delegate. So we start with a login block that is giving us your current state. We were an initial state. And then an event came, a login form change, right? And then we're going to trigger a certain validation. That's our next state. So now, just by giving these logs, you know that we're talking about a login form, right? What comes after that? We were like the case where we couldn't validate the form, but another form change event came, and now we were able to validate that. I didn't print on purpose username and password. Probably what happened here, like someone type a username, someone type a password, so now the login button is enabled, right? Let's keep going through that. Now that the login form is valid, the next event is the login submitted. Probably someone tapped the button, and now we're triggering a login in progress, right? So now from the login in progress, and again from the same event, login submitted, right? Like probably there was a network call and something that's happening. Now we get that the next state is login success. Probably we validated on the server that that user is an authenticated user. So now we're going to the authentication block, right? Like we want to remove the non-authenticated features from our widget tree and take the user into a more complex part of the application, right? So in this case, we were in an authenticated failure state. We were not authenticated, but we received the event logged in with a user. In this case, it's a fake user. So now the next step that we're going to trigger is the authentication success, right? And therefore, after that, we're in the home page. We're in the home block, right? And it looks like we're in the stores tab, and there was an event that was tab selected with a certain index. And therefore, that's going to trigger our next state, that it's probably the second tab or like the tab that was in the index 1. That is the tasks tab, right? And finally, from the task tab, again, you tap on the index number 2, and then you go to profile tab. You've never seen this application, but you see how straightforward it is to debug. Even if you don't have the app in front of you, you have every single interaction that the user had from here, right? Well, but you're going to be like, Jorge, like those are print statements. What's cool about that? Well, actually, it's a little bit more clever than that, right? The way you can capture these logs, you can just inject it into your analytics system, into your like crash reporting or whatever you want to use, right? So as part of VNW, we open source this library called Lamberdash that has literally 5 methods. Put Lamberdash to work, and you just give it clients, right? And we have plugins. It could be like print on the console, but also could be like, hey, send this to Firebase Analytics or to Sentry or to whatever reports in your own server, right? Just implement a plugin and that's it. And then you just have a few APIs that look like any other logger in the world. Log a warning, log fatal, log message, log error. But if you combine this with the BLoC Delegate, this is where the magic happens, right? Now, if you combine your BLoC Delegate with Lamberdash, you get all that log message, log error. It's going to be reporting to whatever plugin you added, and you're going to get those same logs in whatever system you want to get them. So if you just want to print to the terminal, go, great. But if you want to do it like also on Firebase Analytics or Sentry, you're going to get it also for free. So as you can see, that's very, very powerful. You will never have to write analytics or debugging logs ever again. So that means that it's cost efficient, right? And we get it pretty much for free just by adding a certain package and using the tools in combination to get this cost efficiency. It's pretty cool, right? At least I'm kind of like coming from a world where I had to log every analytic like manually and all the stuff. Getting to be in this scenario is very, very, I don't know, it blows my mind. So what we have so far is something that looks like this, right? We had our UI, we have the BLoC in between, and then something that we call repository. Again, like it's just like kind of like a domain layer or like part of like combining data sources. And because we have a single input and a single output, we have that delegate, that line in between that is spying to every single thing that it's happening between our UI and then BLoC, right? So far, what do we have? That BLoC is simple, that you can be really productive, right? That it's cost efficient as well, like we're reducing the amount of things that we have to do, but we're still getting them, and it's robust. So I could actually finish the talk in here and we would be okay, right? But I think, or actually I'm gonna raise this question, do you think we can do more, right? Well, there's, in my opinion, something else that we can do. Flutter, one of their premises is like, you're not gonna notice that you're running a Flutter application. It's giving you native performance out of the box. Could be 60 frames per second, like whatever you wanna have, right? So how can we validate all that? Again, like it's simple, it's productive, cost efficient, but like I think we can do a little bit more in the robustness area. Because we've only seen how to test our business logic. We haven't talked yet about Flutter or anything like that, right? So is there a way to measure our performance, right? Like if you saw Philip's talk yesterday, he was talking about fixing an issue. But what if we can prevent having an issue in the first instance, right? So that's why we open source also this library called OSI that works in combination with the Flutter driver with like pretty much end-to-end tests, right? And it's very simple. We just want to take screenshots of what's going on during our integration tests. But also now that we're running integration tests and our application is doing animations and things like that, wouldn't it be cool if we can actually validate like, hey, are we running at 60 frames per second or we're actually having like a performance issue somewhere, right? And if we have it, do we want to break the build, right? Like if you're in a CI/CD environment, that would be something really cool to do. So Flutter driver test looks something like this. This is the case of the counter BLoC again, like the counter application. This is not even tied to BLoC, but like pretty much you get access to this Flutter driver and you get a connection. Then on your tear down, pretty much when you're done testing, you just want to dispose that resource, right? You want to close the driver. And then what you do is like, okay, I can wait for certain things to appear on the screen. So I can have like in this case, an expectation, but I can also interact with my application, right? Like I can tap on buttons, I can fill a form, I can swipe, left or right, whatever you want to do, right? So doing integration tests, very simple, just a few lines of code. But how does it work with OSI? So with OSI, we just add a few lines of code and now we can get performance reports as well. So in this case, we were getting access to our Flutter driver. We just add OSI in there. And as part of our setup, we set up our driver. And then with OSI, we just say like, hey, init OSI with this driver and give it a group name. Why a group name? I said that we're going to capture a screenshot. So one of the things that OSI is going to give you is a very nice web report where you can group your integration tests by features, right? So imagine like you might have a login form, your home tab, your store tab, whatever you want to have, right? So that's a way to kind of like group everything in a nice way. Then when you tear down everything, you close your driver resource, and then you tell OSI, if you want to get that web report, please generate this web report for me, right? And then as part of your test, if you want to get profiling performance or like performance reports for certain interactions, you just wrap your test within this profile performance and just give it like a report name, counter 0 in this case. And what we're going to do here is, again, what we were doing before. Wait for something to happen. And then if we want to take a screenshot, as you can see, we can take a screenshot. Or even in the complex case where like there's some interaction, but you still want to measure the performance, you do the same thing. You wrap it in a profile the performance for the interactions that are going to happen inside. And at the end, you can take or not take a screenshot. It's up to you. So as you can see, three methods for OSI: generate HTML report, profile performance, and take a screenshot. And with that, you're going to get something that looks like this, right? you get this web report generated with like all the screenshots that you took inside that. This is running actually in debug mode. Philip said don't do it. I say the same thing, but I made that mistake. But you have a tab that says performance, and whatever you see red, that means bad things, right? So probably in that test, we missed like a few frames, so we were not rendering at 60 frames per second, right? If you want to get more details, you can actually get the reports printed in there, whatever you want to do with that. So now, again, we had like users outside actually the BMW world using Aussie, and we got like really positive feedback. I'm actually even thinking about simplifying the API a bit more because I realize now that with extension methods, probably I don't need to create an Aussie instance. You might do that on top of the Flutter driver. I'll keep going. So yeah, pretty good. So far, like these are the tools that I think, in my opinion, helped us to scale our practices, right? So we're talking about having complex problems, but try to provide simple solutions, because it's only when on top of those simple solutions you can keep growing. If you have something else that you like, try to just be like mindful about those things, right? Try to have a good like discovery, measure your performance, understand what's going on in your application. And finally, like, you're using Flutter. I think using Lambdas at least is kind of like a no-brainer. You get a lot of things for free. But also, if you want to use Aussie, it's a very, very powerful tool that will give you a lot of information about your application without almost zero effort, right? So with that, pretty much that's all I have. Again, my name is Jorge. You can find me on Twitter under Coca Ramos for the Spanish population. I also run the Chicago Flutter meetup, so if you're ever in Chicago, it doesn't even have to be during a meetup. Just reach out to me or Felix or whoever you know in Chicago. I'm glad to grab a coffee or whatever it is, right? But like, I think it's a nice way to kind of like get to know the community. And finally, also, like, if you have any questions about Flutter or things that we've been doing at work for Very Good Ventures, they're kind of like known in the world for doing this first application in Flutter called Hamilton that everyone loves. So also, if you haven't watched Hamilton, I recommend it. It's amazing. But other than that, like, thank you so much for coming, and happy coding, everyone.